So the indeterminate forms of L'Hopital's rule is basically 0 over 0 or infinity over infinity. So I think I've talked about this in one of the previous questions, so I'll not repeat how to do that differentiation thingy. But the requirement is that it must be in the division form. But there is always a way to convert something that's not division to division. So for example, if you want to take the limit as x goes to 0 of x to the x. So if you look at it, then it's 0 over 0, which we don't know what that is. If it's 0 to any positive power, then 0. So say 0 to the power 1, then it's 0. But if it's anything to the power 0, say 1 to the power 0, is equal to 2 to the power 0, is equal to 3 to the power 0, it's all equal to 1. So it's either 0 or 1, but we don't know what this is. So that's when we use the e to the log trick again. So e to the log is the same as the original thing, and we take the e outside the limit, which you get this. And the way to convert this to the dividing form is basically you take log x on the top and do 1 over x on the bottom. So that when you flip this, it gets to the original function, but this is fx over gx form. And when x is going to 0, this top is going to minus infinity and bottom is going to infinity. So it's infinity over infinity form. So we can actually apply the L'Hopital's rule. When we apply the L'Hopital's rule, taking the derivative of log is 1 over x, taking the derivative of 1 over x is minus 1 over x squared. So when you simplify this, it only gets to minus x. And x goes to 0 of minus x is just 0. So it's going to 1. So that's why this whole limit is 1, not 0.